So yeah, hey everybody, my name is Jordan Last. I am CEO of a company called Demergent Labs. We are building fundamental open source tools for the Internet Computer Protocol. And just to understand a little bit more, you guys had a meeting yesterday to already go over the basics and fundamentals of the Internet Computer, is my understanding. Is that correct?
Yes, correct.
Awesome. So then I'm happy to answer any questions you guys have still about the Internet Computer as I go. I'm going to be sharing my screen, so I won't be able to really see the chat. But I would say feel free to just unmute yourself and interrupt me if you do have a question. So basically, we're going to just dive straight into coding. So my company is building two projects in particular. One is called Kybra. Kybra is the Python development kit, essentially. And the other is called Azel, which is the TypeScript and the JavaScript development kit. Tomorrow, you guys are going to learn about that, is my understanding. But tonight, we're going to focus on Python. But just keep in mind, everything we're learning here is essentially equivalent to what you can do with the TypeScript and the JavaScript development kit that you'll learn about tomorrow. So first things first, the project is called Kybra. The headquarters of everything is right here at github.com/demergent-labs/Kybra. You can see all the work we're doing and everything. Right now, we're focusing more on the TypeScript and JavaScript CDK. So we haven't touched too much in the last few months, but these two projects are both very important to us. One disclaimer is Kybra is a beta project. So it may have unknown security vulnerabilities due to various things, and it's new. You could run into bugs or problems. So just an FYI. The most important thing here after the disclaimer is probably this examples directory right here. This examples directory has tons, like 60 or 70 examples of all the APIs available to you, just how to do basically internet computer programming using Python. So if the documentation doesn't cover something, look for an example that might cover it. So that's just the examples directory in the repository. And then from the README, you can always get to the documentation, the Kybra book. Click it, here we are, same thing. The Kybra book is designed to be basically a giant tutorial. So if you just go chapter by chapter, it should guide you along pretty well and understand the basic concepts that you need to know. So MIT licensed, basically everything we do is open source. That's the way I like it. Chapter 2 here, by the way, is going to be very good for getting an in-depth understanding, at least a more in-depth understanding of the trade-offs of the internet computer and of Kybra compared to doing something else, right? The internet computer is not a perfect solution, just like AWS is not a perfect solution, just like Ethereum and Bitcoin aren't perfect solutions. The internet computer has chosen a very specific set of trade-offs and a set of design choices that allow it to excel in certain areas and to not excel in others. So chapter 2 kind of dives into a lot of that material. But for us, we're just going to get started. So chapter 3, installation. This is the hardest part for everybody. You need to know right away, you must have a Linux machine or a Mac machine, or if you're on Windows, you need to use WSL, and you need to use the latest WSL, like WSL version 2, I believe is the latest, but version 1 definitely will not work. So if you're on Windows, you should just make sure you have WSL right away. And I think it's better to program with a Unix-based machine anyways, so I might as well get it over with. Then you need to install Python. You need to install a very specific version. If you're like a mastermind and you know what you're doing, I don't know, maybe you don't have to follow these instructions exactly, but I highly, highly recommend you not do that. We're dealing with a lot of constraints. We're actually Kybra and the Internet Computer is a WebAssembly environment. This is not Python just running on x86 or ARM like your local computer, where it's extremely well supported for decades and has all APIs you could possibly want. We're actually compiling a Rust interpreter down into WASM and executing all your code in a WASM environment. So that's completely different than most Python programming. And also, not only is it a WASM environment, but it's a decentralized, Byzantine fault-tolerant, replicated compute environment. So it's just different, and we have some limitations that we are basically constantly working to overcome. So all that is just trying to emphasize that you should probably not deviate from what the instructions say. So installing Python, I highly recommend just using PyEnv. You basically just run this command here. When you install everything, so let's just pretend, let's just open a completely fresh terminal. You just run the command. Because I already have it installed, I'll just do it from scratch for you. When you run these commands, make sure that they completely finish and that you address all errors before moving on to the next command. A lot of people just copy this whole thing and then it gets really complicated. So everything is completely fine, just based on experience. I know that. Also, it's not telling me that there are any errors, right? I don't see any errors. And also, all this does is it creates a .pyenv directory in your home directory. So if I really want to check, I can go in here and everything's looking good. Okay, so that just installs PyEnv, which allows us to easily install specific versions of Python. So now I'm going to install Python version 3.10.7. Just copy this command and execute. I think that takes a little bit to download and everything. Okay, while we're waiting for that to install, the next thing we want to install is called DFX. DFX is not specific to Kybra. DFX is basically the command line tools that let you interact with the Internet Computer. So it doesn't matter what language you choose, you'll be using DFX on the Internet Computer. You install it with this command. So, technically I don't need to wait for that to finish. So I'll just come over here. And I'll install this. Make sure you install this specific version. That's just the latest version we've tested against. So newer versions might work, but all of our tests are running against this version. So just waiting on things to install. All right, while those are running, next you really, 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 really want to have the Python VS Code extension created by Microsoft. This is going to give you type checking, which Kybra requires currently, and it's going to make your life better, in my opinion. So, sorry, three things we're installing: Python 3.10.7, DFX, and the Python VS Code extension. DFX just finished. So first, check for errors. No errors. Then you can run the DFX command. This is a good way to test anything you install. Just run the command. Okay, look, it actually outputted stuff. And oftentimes there will be a version option that you can tack on to something. And so, boom. So yeah, DFX looks like it has been installed perfectly well. And Python, it looks like it's installed. I don't see any errors. And then to check if Python has been installed correctly, I can I can go to the path of the executable. So that's basically what PyEnv did, is it created a Python executable inside of the local.pyenv directory under versions 3.10.7/bin/python. And you can install all kinds of versions, and you can know exactly where the executable is. So you can just pinpoint and make sure for whatever you're doing, you have the right version. Okay, so cool. I've got myself a little Python REPL thing. So I have successfully installed everything. For some reason, whenever I do it, it goes fine. But not whenever, but a lot of times when people are using Kybra, they have all the craziest problems possible. So that's why I'm just going very methodically through it to make sure everything goes well. Okay, so if all that is going well, then we're doing well. Next is the Python VS Code extension. So you go to VS Code, you just go to Preferences, Extensions, search for Python. You want to grab the one right here made by Microsoft and click Install. Nothing too crazy. Now, once you have it, it's not going to be that useful unless you turn on this setting, python.analysis.typechecking mode. So if you go to VS Code, Preferences, Settings, and search for python.analysis.typechecking mode. So let's do that. Preferences, Settings. I'll just paste that in. Right here. The default is off. I mean, you should not have it off. At least basic, but why not just go strict? The strictest type checking you can get, that sounds great to me. You want your code to be safe. Okay. That's it for the basic installation. We won't find out if everything's working until we actually deploy an application. When we deploy, you might run into a host of problems. There's a common installations issues section here. You might see an error, linker CC not found. Is CMake installed? The Python SSL extension was not compiled, blah, blah, blah. Basically, sometimes you just got to install some of these things on your machine. So keep that in mind. But chapter 3 is all about basic installation. Hopefully, you can make it through that without too much pain. And then you're ready to actually program. Chapter 4, Hello World. So we're going to make a Kybra program. It's just like making any other program. I'm going to just navigate to a place where I can there we go. I'm going to just navigate to a place where I have some free space. Just change directory somewhere, or you can use your file system, whatever. All we're going to do, let me just get rid of that one. Let me just clean up all this stuff. Okay. Look, I just have an empty directory. I'm going to make a new empty directory for my project, and I'm going to call it Kybra Hello World. And this chapter is just a step-by-step tutorial. So first thing, and you don't have to run these commands. You could do it in many different ways, but it's easy to just do that. Okay, I've made a directory called Kybra Hello World. Let's just go inside of it. It's just completely empty. Let's make a directory called source. That's where we're going to put our source code. Let's make a new empty file called main.py. And let's make a new empty file called dfx.json. And finally, let me just close this. Let's just open VS Code in our new directory. So check it out. This is our project so far. It's just a dfx.json file. This file is a special configuration file specifically for internet computer applications. It's just like a package.json file or similar to a requirements.txt file. It's not complicated. It's not scary. It's just a configuration file. Main.py, just a Python file. So there's really nothing new or too crazy going on here. So let's first, what should we do first? Let's see what this tells us to do first. Well, first, this tells us to make a virtual environment. So let's just do that. Just copy this command. This is used the Python venv command. It makes a new virtual environment called venv. So you notice right here, we have a new folder called virtual environment. And this is by the way, I'm not really a Python programmer. So I have done a good amount of Python, but it's not the language or the ecosystem I spend my time in. My understanding is virtual environments are quite common, though we are going to remove the concept pretty soon because I think it's unnecessary complexity for you. But for the moment, just create it and source it. All right, now we've got a virtual environment. Very nice. Now we can pip install Kybra into our virtual environment. Perfect. Okay. Now that we've done that, we can start to do some actual programming. I mean, the easiest thing is to just copy this thing and throw it in the main.py. All right. So notice when I did that, it has all these squigglies. I have my Python extension installed. I have my Python. If we go back to installation, I have my Python.analysis.typechecking mode set to strict. So what could be going wrong? My guess is VS Code didn't automatically detect the virtual environment. So the first thing I'm going to try is Control-Shift-P. I'm just going to reload VS Code. Now what I'm hoping is that VS Code picks up the virtual environment directory, finds Kybra inside of there, and gives me all the types. Okay, well, it didn't. Oh, well, that's disturbing. This definitely did not happen a few days ago when I gave the same presentation. Okay, let's just go check everything. Go to our extension. Definitely installed. Let's do Python.analysis.typechecking mode. Oops. It's set to strict. Okay, here's my virtual environment. So what could be going wrong here? Okay, so sometimes it might not have chosen the right interpreter. So down here in the corner, you can choose your Python interpreter. So right here, it's pointing to PyEnv 3.0.7 bin Python, my global PyEnv installation. But it also gives me the choice to choose bin Python from my virtual environment, which should be this exact same version. So I'm thinking if I click this, there we go. So I don't know. Sometimes it's finicky, sometimes there's all kinds of settings. But I guess make sure VS Code picks up your virtual environment. Usually, I bet it would have done it if I had opened VS Code after I had created the virtual environment. All right, but now everything's typed. So here is the Kybra module. This is where you're going to import everything from. Notice we are importing three things. The first is a decorator called query. The second is a decorator called update. And the third is a type called void. In Kybra, everything needs to be statically typed. Not everything, but the internet computer, not even every internet computer API, but basically things that touch the internet computer, you need to use types. And things that are just your own internal things or global variables, you don't need to use types. Like right here, you don't technically need to type that as a string, but it's nice to do. But for any kind of a function that you're exporting to the outside world that you expect people to call, you're generally going to type that. So yeah, let's just take a look. So right here, this is a global variable called message. Its type is string. It's just an empty string. There's nothing crazy about it. It is stored on the heap. That's just how the Rust interpreter works. That's how most languages, at least JavaScript and probably other any languages that let you have global variables, they're going to store them on the heap. Remember, you have the heap and the stack, and you have maybe your hard drive for the file system, stuff like that. So message will be stored on the heap. And what's really cool is that the internet computer automatically persists the heap across requests, basically. So you can actually store a lot of arbitrary information just in global variables. You don't necessarily need to grab a database for everything if you don't want to or if your application doesn't call for it. So that's all that's going on there. This is called a query method. This is just a function called getMessage. All you do to expose it to the outside world. Now, query and update, this is the way that you expose your functionality to the outside world. What we're building here is called a canister. It's just an internet computer application. A canister will run on the internet computer network. How do people interact with your canister? How do clients, web browsers, mobile apps, other canister servers, how do people interact with your canister? Generally, through query and update methods. You can also do pure raw HTTP, but this is a nice abstraction that the internet computer provides. So what is a query method? It's a function decorated with query. What does it do? It's basically a read-only method. If you want people to be able to read data very quickly and skip the blockchain consensus, then you'll make a query method. So, for example, just reading the message, just query. That's it. If you want to actually change data, so it's read-only. So if you try to change any global variables, they will not be persisted. They'll be thrown away. The changes will be thrown away. If you want to persist changes, then you'll decorate your function with something called an update method. An update method can actually write data into the heap or other locations, and the data will be persisted. Update methods take a couple seconds to complete. If you do, cross-canister calls or outgoing HTTP requests or something, it could take even longer. But just a normal, regular HTTP request or update method call will take a few seconds to complete. That's because it's going through consensus. All the nodes running your canister are securing the change, basically making sure that at least 2/3 of them all agree that the change is correct. And that's why it takes a little bit longer. That's why it's more secure as well. And there you go. That's our basic application. Let's go back to chapter 4. So yeah, we went through the main.py. The dfx.json file is just a configuration file. You can generally copy paste this configuration. It's not that important what these fields say. I mean, you can basically copy paste these across all your projects, but basically there's a field called canisters or a property called canisters. And you just make a property for each canister that you want to deploy. Remember, a canister is the application unit. It's basically a WebAssembly module with the WebAssembly's heap and other storage locations and the binary that's actually the code running. So No, this is just a build command that actually compiles everything. This runs to upload everything after compilation. Here's your WASM binary. This tells it to gzip. And this is a file that I will talk about later. But yeah, you can just copy paste that. And we're going to make this way simpler in the future. It's a little bit unnecessarily verbose at the moment. Okay, now that we have code, now that we have our dfx.json, we're ready to actually deploy locally at least. So we're going to start a local internet computer replica. Oh, yeah, so I already have a replica running, so I need to turn it off. Oops. Sorry, I've been running multiple versions, so I need to add the -- clean command just to wipe everything and install it from scratch. Okay, so my replica is now running in the background. If you ever want to stop your replica, you can just do dfx stop. A replica is just a node, basically, right? It's like running a Bitcoin node or an Ethereum node. It's running one internet computer node on your machine. It's completely local. It's not connected to the actual internet computer network. It's just for your local testing. Actually, I don't really like running them in the background. I like just having a terminal open that's completely dedicated so that I can see the logs and I can see if there are any errors or anything. So I'm just going to leave that open there. And I'm going to make a new terminal to deploy from. Remember, whenever you deploy, you need to make sure you create a virtual environment. So I've already created the virtual environment, so I just need to activate it. There we go. And now that we have started our local replica, the only thing left to do is to do dfx deploy. This is going to compile everything down to a WASM module and upload it into the replica. Mine's going pretty fast. Yours is going to take 5 to 10 minutes the first time, unfortunately. Obviously, that's not desirable, and we would love to change that, but we are constrained by a few things at the moment. So yeah, everything has compiled successfully, and now we're going to chunk upload everything into the canister. It might take a bit. One thing I need to point out, if you ever are asked for a password while using Kybra because of a dfx command, that probably means you have an encrypted dfx identity. The identity is basically a name and a key pair that dfx uses to sign things to authorize what you do. Kybra does not support using encrypted identities at the moment. So if you're asked for a password, you really must create an unencrypted identity. If you don't, you're going to run into crazy problems while trying to deploy that you do not want to run into. So just keep that in mind. Okay. So every time we chunk upload the Python WASM module, and then the first time you deploy a canister, we chunk upload the entire Python standard library. That's what that is. Okay, I've successfully deployed. Now we can interact with our canister. One of the best ways is to just copy that URL and go to your browser. Notice we have our query method, get message. We have our update method, set message. This is how we're actually going to interact. this is using something called the JavaScript agent. This website is, when I click query, it's actually creating the HTTP request it needs to create, putting everything into the right formats and encodings, and signing the messages, the HTTP requests, and then sending them down to the replica, getting a response, decoding everything, doing all that for you. That's nice. Okay, so obviously get message. Remember what it does? It just returns message, so there's nothing there. So it's empty. Set message will actually go and write into the global variable. And remember, the heap is persisted. So if we query, hello world. Pretty cool. You can also interact with it from the command line. dfx canister call, and then you put in the name of your canister, and then the method name, hello world. And if we want to set the message, we can do the same thing, and we can pass in our parameters. Different message. There it is. Different message. Different message. Okay. I mean, I'm going to pause there for the moment. Are there any questions? Because that is the most natural point to pause. We've gone over installation and deployment of a simple application. And I'm going to guess someone has to have a question. There's only 16 people. You don't have to be afraid. Nobody?
I guess, no. Just like how like we're using like Python, right? Then they like all I guess would correlate to like Python types and stuff. Is it going to be able to do like, let's say, like every single kind of like method I would use in Python? Would it also, or sorry, I'm wording this really weird. Um, I guess maybe I can go with an example, like really simple. So, you know how like arrays, you have like methods like push or like remove, or are they like all gonna, I guess for like all types and stuff, will all of those methods also work, or have
So
been
yeah,
like
Kybra's so types are part of Python. This is not anything Kybra created. So it's just using Python type hints. There's a PEP, I think is what they're called, that supports this. So generally speaking, most things pure Python are supported by Kybra. Not all of the standard libraries supported because the Internet Computer itself doesn't support some things. For example, you can't do TCP sockets on the Internet Computer. You can't do HTTP requests using the standard library. You can do it a simpler form of HTTP request using an Internet Computer API. So yeah, the Internet Computer has certain limitations because this is a different environment. It's like running Python in the web in your browser. It's a different environment than running Python on a server, right? So you can't do everything in a web browser running Python that you can do on the server running Python. But type hints and pure Python stuff is generally going to be supported.
yeah. Yeah, that's good to know. Thank you. Because I was looking at like the candid stuff and I'm like, okay, this looks slightly different. So
Yeah,
yeah.
yeah. So I'll go into I'll go into candid right now after I answer any other questions, and I hopefully it will become more clear what you need to use these specific types for. because it's really just the interface of your application. Once you're inside your application, you can just kind of do free-for-all Python.
Nice.
And I'll describe that.
Okay, thank you.
You're welcome.
Another question that I have. So if I'm developing an app using Python, are there any like known frameworks that are supported already on the IC?
What kind of frameworks?
Like app development frameworks, front end related frameworks.
So for front end, you could do whatever you want.
Okay,
Front end is not constrained by the internet computer.
I see.
Yeah. For the back end, I mean, Kybra is the sole backend framework currently on the internet computer. It supports, I mean, you should be able to use, I mean, this is the framework, I guess, right? All these things with the types, and I'm going to go into more detail now. It's making development very, very easy for you. So if you need other functionality, though, you can go to PyPy and pip install things. I don't know which things work and which things don't, because how would I know that? We would have to like download every package and test them out, right? So we haven't tested all the packages, but generally speaking, anything that is pure Python, so not using the C extension or the C API, anything that's just purely written Python using Python and the standard library that doesn't use unsupported internet computer, APIs that wouldn't be supported on the computer, should work. So yeah, basically just reach for PyPy packages you need, and just keep in mind that if they use the C extension or C API, they will not work. If they don't use those, there's a chance they will work. And yeah, I feel like that's generally the story currently. The idea is eventually, you shouldn't even have to ask these questions, and I should be able to say everything works. But this is not a centralized traditional cloud, right? This is a different environment. So there are constraints. Anybody else? Okay, then let me finish off with diving in a little bit more into the type system and what it's for. So like I said, these types are not custom to the internet computer or to Kybra. Python has a type system, and you can use it, and it's really cool. What we have done is we've kind of commandeered the type system for our own needs. So for example, we made this type called void. It's using standard Python, but we decided to call it void, and we decided to force you to put it on here. So that's a little bit different. What is all this? Well, these types are basically to help. Sorry, don't look at the file. These types are basically to help with serialization and deserialization. If you have any kind of network application, you need to deal with, how do I get values like source code language level data structures running in one process. For example, in a web browser, in JavaScript. How do I get an object with keys and values and everything? How do I send that object down in a request, have it hit a server or a canister, right? And maybe that server is written in Python or Rust or some other language, or even in JavaScript. How do I then receive that value over the network and turn it back into a language level data structure? This is a problem that any application needs to solve. Generally, what you do is you serialize the value on the client, send it across the internet, and then you deserialize it when you get to the other side. One of the most popular ways of doing this is called JSON, right? And JavaScript just natively supports JSON. So You just say, JSON.stringify and turns it into string. Throw that into HTTP body, send it across the network. On the other side, you get the string. If you're using JavaScript, you say JSON.parse. If you're using Python, you say JSON. I forgot what it is, but you just import. Import JSON. Come on. Oh no. Sorry. No. Import JSON. There we go. You import JSON and you do JSON. I'm gonna guess load. Right. You do JSON.load, and boom, it turns it into a Python, dictionary or whatever it is, right? So you need to deal with doing this. The Internet Computer has embraced a new language that they create, that Dfinity, the foundation that created the Internet Computer, created, called Candid. Candid is an interface description language. It basically makes serialization and deserialization very, 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 very simple in the best case. So that's what we're using these types for, basically. We're using these types so that you don't have to really think about the Candid serialization and deserialization. The values will just be serialized for you automatically and deserialized for you automatically. So that on the front end, or whatever client you're using, all you do is deal with really nice high-level concepts. Strings, null, bool, numbers. Here is an example of the Candid language. This file is called a did file. It's generated for you automatically. So Kybra will actually look at your types and create this file for you. This file is then consumed by other libraries, clients, services, whatever, to then be able to interact very easily with your canister. So you shouldn't be editing this file manually. It'll be generated for you. But you can see that it's just describing your canister. Service is just a canister. And it says, look, we have a method called getMessage. It has no parameters, but it returns a text value, and it's a query method. And we have a method called setMessage. It has one parameter that's a text value, and it doesn't return anything. And because it doesn't have a query annotation, it's an update method. So yeah, Candid is what is used for serialization and deserialization. So that's where you have to use the types. You have to use them if you want to use this automatic serialization and deserialization. So right here, we can just get rid of that. We don't need that if we don't want to have it. I don't see a reason to get rid of it though, so I'll just leave it. You have all kinds of types you can import. You have nats, nat64, nat32, nat16, int. Int's actually just the native Python int64, int32, int16, bool, null, vec, opt, all kinds of types. If you want to know what all these types are, you can skip. I mean, we basically covered, by the way, all these chapters. Query methods, update methods, and just an overview of the Internet Computer and canisters and deployment. So chapter 11 is all about Candid. So these are all the values that you can use to make interacting with your canister super easy and super interoperable. And basically all canisters do this. Any canister you interact with is going to have a Candid file available so that you can very easily interact with that canister. And because the whole ecosystem is doing this, it does make it quite easy to interoperate. So yeah, there's all those types. One thing I should probably show you is how you make something non-trivial. And that'll be probably the last thing I show you. So let's just delete all this. We're going to do two things. We're going to first make a key value store where the keys are strings and the values are strings. Then we're going to make like almost an actual database where the keys are strings and the values are actually like a record type. So first thing I'm going to do is I'm going to make a little object called database. It's just a dictionary with keys as strings and values as strings. Then I'm going to make a query method, which is called get, where you just pass in your key and you get back your value. What do you know? Done. Now I'm going to make a little update method, and I'll call it set, where you'll pass in a key and a value. And we'll just return the value. db key equals value, and then I'll just return value. Okay, I just want to show you, look, this is a little simple database. Let's just deploy it. We're just going to use a dictionary to store key value pairs. Keys are strings, values are strings. Pretty awesome. Chunk 1, chunk 2. Then we wait for it to finalize. And then we can go play with it. Notice that it generated a new candidate file for us. Oh, wait. Oh, hold on. I think it does it at the end. There we go. Get text text set text text text. There you go. Now, by the way, this browser tool is using the candidate file to know how to do all this. Okay, so let's get something with key 0. It's going to break because there's nothing there. Let's set something at key 0. Yeah, now there is something there. And we'll do it again. Yeah, 0's there, and then 1's there. Cool. This is a database. But it's just strings. So if you just want to do everything in JSON, then this would work. But you probably don't want to do that. So let's make something called a record. You just make a class. We'll say it's a user. You inherit from record. And let's say it has an ID called string and a username called string and an age, which is an int. And then let's update this to be a dictionary of strings to string keys and user values. So now get will return a user. Aha. And now the value should be a user, and we'll actually return a user as well. Okay. Now our simple database is a little bit more advanced. And it can store arbitrary. Now this database is basically acting as one table with rows, right? Every entry is basically a row in the table. That's the primary key. And these are each of the columns: ID, username, and age. Okay, let's try to get record 0. Nothing there. Now let's set record 0 with ID 0, age 32, username, last name JS, call. All right, we got our record back. And now if I query, look, it's a record. ID, age, username. Pretty cool. So you could just keep doing this, right? I could say maybe users, and then I could maybe say like blog post and make a blog post, right? And then I could say here that I have blog posts, and this is a vec of strings because I'm just going to store the private keys, right? And then you'd have to write logic to like do filtering. I mean, if you're going to make a database like this, you would have to implement everything by hand. On the computer right now, we don't have the best database solutions. So people are generally doing a lot of this low-level work by hand. my company is planning to create a GraphQL database, which I got to a beta state, but we just haven't gotten to it yet. But yeah, this is generally what you'll do. You may have noticed, though, that every time I deployed, it wiped the previous data. That's because when you deploy new code, the heap actually gets wiped. So if you don't want that to happen, you can use a special data structure called a stable B-tree map. And a stable B-tree map will replace these dictionaries. So I'll say users equals stable B-tree map. I'll put in again my keys and my values. You have to give it a memory ID starting at 3, unfortunately. And then you have to set the maximum key size. Let's say 100 bytes and the maximum value size 1,000 bytes. Okay. Now I can say users dot get. So this has a little bit of a nicer API. Now I need to import a type called opt. And opt is basically null or the type inside of it. And then over here, if I want to set, I can say db.insert, not db, sorry. Users.insert key val. And maybe I want to get all of the users. Now import back again. There we go. So now we have like a little database getting built. This will now persist. You need to start with memory ID 3, FYI, because unfortunately 0, 1, and 2 are just already used. And you have up to 200, about 250 of them that you choose from. And you can read more about stable B-tree maps, by the way, in chapter 12 and understand. What's nice about these is you can deploy new code and the data will persist, and you have 96 gigabytes of storage. The heap is only 4 gigabytes, but still B-tree maps have up to 96 gigabytes of storage per canister, which is nice. Okay, so now let's try to get key 0. Notice it returns a nice null instead of an error. Let's get our users. There aren't any. Then let's create some users. Nice. Now if I get ID 0, I've got my user. And if I get all the users, it's a vector with all the users in it. I can make one more. And there it is. Pretty cool. Okay, those are the basics. Any questions before our time is up?
I have a quick question.
Yeah.
So it's about the stable tree map. You said it has 96 gigabytes of data. So if you, this is a crazy question, but like if you create 2 stable tree map objects, are you able to like scale that up to like 96 times 2, or is it that?
No, it's per canister, per application. They all share the 96 gigabytes. Yep.
All right.
But you can make another canister, and then you could have 96.
And then share both. Okay. Thank you.
Yep.
Yeah. It could be more relating to the instead of Kybra, you know, like Azul for TypeScript.
Mm-hmm. Mm-hmm.
I did try out making a project with Azul once.
Oh, sweet.
With like the MPX Azul, but I've noticed when I did that a bit ago, there was this you know, deprecated text encoding. a dependency that I would notice. Is
Mhm.
that like very important for or related to the candid stuff in TypeScript, or
Is this an error that blocked you?
it doesn't block me? I can like launch my application just fine. It's just I was
Oh.
wondering like how important it was.
No, it's probably not very important, I would say.
Okay, so I don't need to worry about. Okay.
Probably not. Do you know what version of Bazel you're using?
I think it should be the recent one. Let's see. I think it's the newest version.
0.18?
Yeah.
Yeah, it shouldn't be a problem. Especially, yeah. No, it's just a warning NPM is throwing probably.
Okay. Good. Thank you.
You're welcome.
Is there any way to link different canisters resources together or share them? Or does it have to be done through like different API calls between canisters?
Yeah, the only way is through asynchronous cross canister calls, is what they call it.
Got it.
So basically, call the methods of another canister from your canister.
Right. Thank you.
And all that is covered in chapter 13, cross canister. Okay, there's a question in the chat. In the case of using ASL Kybra, does it simply depend on whether you want to use Python or TypeScript? I mean, basically. And you can also use Rust. You can also use Motoko. Motoko is a language created by Dfinity. Rust is a hardcore software engineering language, so it's just very difficult. And Motoko is an esoteric language that nobody else uses except for this ecosystem. So, yeah, all these have different trade-offs. ASL and Kybra are similar in their maturity, but I mean they have different little nuances as well. But I think it mostly comes down to just. Sorry, I heard a sound over there. It mostly comes down to yeah, Python or TypeScript or JavaScript. In ASL, you could do pure JavaScript if you want. You don't have to use TypeScript. And Kybra soon, when we get to it, we basically re-architected ASL in the last couple months, and we want to apply the same architecture to Kybra. And that would make it so that you don't have to do the type things we did necessarily, unless you want to. So. We'll see how that goes, though. I don't know if all the concepts will translate perfectly over into Python.
I have one question.
Yeah.
So, in your opinion, like I know you said it just depends on the language, but which is the preferred language or the preferred framework to use for the internet computer right now?
What do you mean by preferred?
So, or like in terms of performance, or the one with a lot more features with it that can be used. I don't know if you get what I mean.
I mean, yeah, I get what you mean. So just to straight up answer your question, it'd be Rust or Motoko, because those are the official languages that are supported by the Dfinity Foundation, and they put
Right.
their work on them. But both those languages have different trade-offs with each other. Yeah.
Yeah. That's fair. Thanks.
No problem.
Okay, if you don't have any more questions, if you would like, Jordan, we can wrap up the workshop. We also recorded it as well, so any of the devs that we have that couldn't attend, we'll share the recording with them.
Okay. Yep. I think everyone's good.
And thanks a lot for your time and hosting the workshop today.
You're welcome. Thank you, everybody.
Thank you.
Thank you, Jordan. It's very insightful chatting with you.